Please welcome Alex Snaps.
Yeah, that's me. It's my first LambdaConf, so awesome conference, like bunch of smart people, very opinionated. And I come up with this title for my slides. I was like, that's really bad. But it's hard to come up with something that's maybe a little bit different. But now I heard it's the last LambdaConf. So who cares what I'm going to do? Not re-invite me for changing my title last minute? Cheers, man. So I changed it to this. Now that my app gets deployed with all that crap, I may as well just use it for my own benefit. And so I called it Abusing Your Infrastructure for Fun and Fame, not for profit, because all you'll see here is open source. And as we heard, there's no money to be made there. So just fun and fame, but that's a good start. So quick of hand up, like who deploys server-side software here? Keep your hand up, like on Kubernetes? Yeah, I know, it's tough. Your Kubernetes cluster run Envoy by any chance? Or do you even know? Possibly, maybe they don't. All right, so who runs code in their Envoy or the ingresses on their Kubernetes clusters here? Nobody? Okay. Why would do that anyways, right? Doesn't sound really smart. So as it's been said, I'm Alex Snaps. I work at Red Hat, so I actually get paid for writing open source software. I work on a project that's called Quadrant, and I'm going to give you an overview of this before we go all the way deep on what happens on the data plane, because I think context matters quite a bit. Previously, I've done a bunch of crazy stuff, scaling platforms at Shopify, writing software for synthesizers, and bytecode manipulation on the transparency team at Terracotta, for those who may remember those days. But I always thought like transparency is a really cool name as a team. All right, so let's change that thing again. Deploying server-side software in the age of cloud, AI nowadays, whatever buzzwords you want to have. I think that helps also get into conferences. So why would you run code in Envoy? So first, you get Envoy, and it is extensible. And I put Kubernetes there and OpenShift, which is Red Hat's take on Kubernetes. You could run code there for latency reasons. Anything that you can do by avoiding doing network hop while you save latency, that's probably good. You probably save on resources that you may otherwise need. I say probably because obviously you wouldn't run your entire application in Wasm in your proxy, but there are actual use cases I'll get to in a sec. And if anything, you're saving on your cloud bill, right? So if you get any of these things down, like you don't necessarily, well, I don't know, maybe Jeff needs another yard or whatever, or maybe not. All right, so some use cases that I've been involved with or am involved with. So rate limiting, authentication, authorization, that's the use case that I'll be focusing on in this talk. There's other reason you may want to do this. So one example is advanced routing. Let's say you have a multi-tenant application and you shard your deployment out there, and now when a request comes in, you go check, oh, that's a request for Steve. Where is Steve? Right? You resolve in what shard Steve sits, and you dispatch the request to a proper shard. Bot protection, you saw Shopify on there, so that was a big one. All the load you can shed, the earlier, the better you're off, right? Bot is an obvious one, because we can probably all agree this is not what your customers, in this case, or a merchant, like want to sell stuff to necessarily. Another one is whoever sat here in the waiting room, like trying to buy tickets or whatever, right? So the problem you're trying to solve is that there is a whole lot of contention on a sparse resource, right? And so if you need to have coordination in there, obviously the more you have system hitting that point of coordination, that's going to make best case like a bad experience for everyone. Worst case, oh yeah, there happens to be a race condition in that thing, and now things get out of whack, right? So again, same thing again. If I can shed all that load prior to hitting the system in the back, so having people in the wait queue, for instance, never hitting the system as they wait, like all is resolved within that entity. Better experience for the user, and your system is less under stress. And another one that I use now to explain like the rate limiting and the auth that I mentioned before is in the context of Kubernetes Gateway API. So who knows about Kubernetes Gateway API? All right, the link's down there. I guess the slides go online later, so you'll have all that. All right, so Gateway API is the next generation for ingresses in your Kubernetes clusters. It tries to address a few problems that we see there. One thing that I think makes it really powerful, though, is what you see underneath, is this role-oriented orientation that they introduced, right? So it introduces a bunch of, I call them like network objects, right? Gateway class, gateway, like routes. And those are to be used by different roles in your organization, right? So I'm gonna focus on two here quickly. So gateway and route. So let's say I'm part of a big organization and I need to make sure that any traffic that comes in is authenticated, for instance, right? To some level. The gateway, this is something that would want to see enforced by the cluster operator on the gateway, right? But how then the routing happens that, like, I don't need to know, like, what all the routes are to your system in the back. Like, oh, if you do a post here or whatever, then you need to have, I don't know, the writer role. Like, that's not my problem. We care about making sure that a set of rules can be enforced at an organization level and handled down there. As I speak, I realize I'm a bit jumping ahead, but the important part is the role stuff here that you want to remember, right? So again, the cluster manages the gateway, whatever that means, and me as an application developer, I manage like how stuff gets routed to my service. There's quite a few implementation out there today, so some of those that you see listed here do leverage Envoy, not necessarily all of them. And it can actually also depend on the gateway class that you see up there. That's the way that me, as a cluster operator in this case, say I want to introduce an entry point in the system. I reference a gateway class that has certain traits, right? You could perfectly have a system that supports many different like multiple of those vendors, and then people decide which one they want to use, for instance. All right. If you want a complete list, these are all the ones that have GA support for Gateway API 1.2, if I remember right. There's more out there. Some are beta. The other, if you want to do all the sidecar stuff and the mesh stuff, there's yet others. So again, the link is down there if you want to see the entire list. So what I just talked about before, in order to extend the behavior of certain of those objects, there is a gap, so a Gateway API enhancement proposal, to introduce what's called policy attachment. So policy attachment built on the concept of meta resources. I don't know how many of you know about that concept, but fundamentally it's a custom resource that you use to augment the behavior of another resource. Policies in particular do this with a predefined base schema. Most importantly, the target refs that you see there, that's the way that I can deploy a policy that targets, let's say, that gateway, and I say, oh, all the traffic that goes in there now needs to be authenticated somehow. If not, you don't come in. And it also introduces this concept of merge strategies, which lets you merge multiple of those policies together to eventually get the result of what we call an effective policy. An effective policy is really what will be enforced when an actual request now comes in and is being served, based on the state of this DAG that you have, that of like your gateway, your routes, the policies attached to them, and how to merge all that together. So if you want to read more on that, there's actually even 2 gaps because the initial one was split in 2. What I just described now as what we call like the inherited policies. There's the direct ones that would be 2648, if I don't mess it up, and 2649 is the inherited one. So the way this works is a bit like this. So on the left, you see like you can define defaults and overrides in policies. So that now overrides from higher up in this diagram there, like override whatever something below would say. The reverse is true for defaults, so that I can set a default at any of those layers, and it gets overridden by a default lower down. So far, so good. So I realize this is probably really, really small, but as an example, I'm not sure how much you can see that, but there is a foobar gateway. We have a drain timeout set as an override here of 60. So the service policy that's below, that's attached to the route, sets it to 100. That's what you see with the red strike through. So this never gets applied, unless obviously you remove that policy above. Now all of a sudden that's the thing that would be applied. Do we have a default in there? Yes, the reverse being true. So default at the higher level sets the connection timeout to 5, but below sets it to 10. So the idea down there is what we call the effective policy. So that's not a real policy, right? It's the result of the calculated policy that we want to see applied when bar service sees a request in this case. All right. So 2 policies I said I would be focusing on is, one is the auth policy that within Quadrant we enforce using Authorino. As you can see, this so I split into columns. There's authentication on the left-hand side, authorization on the right-hand side. You mix and match as you see fit, depending on your use case. You may not even care about one or the other in a given policy. Supports a bunch of options for you to enforce what you may want to enforce. But since that's not a subject of the talk, I'm going to just skip over this for now. So if we apply the same logic that we had before, now we have 2 auth policies attached to the gateways that, again, probably like the cluster administrator would have set up to that. And me as an application developer come in and say, all right, so auth for anything external, which is the gateway 1 that you see there, says that you need to be authenticated using OIDC. And there is an additional rule that adds to the HTTP route rule down there that's a post, put, del, or delete to anything. We want to make sure that the person has the writer role associated to that. So now the 2 get combined, and when a request does a put on something, we make sure that this is enforced, right? The other one is, so to explain the logic on how this works, you can target multiple things. So HTTP route 2, the R2 on the right-hand side, is wired to 2 gateways. So the gateway 1 and gateway 2. Gateway 2 says we don't allow anything in, and the gateway 1 allows the OIDC authenticated traffic through, right? But then down there, we decided that actually we authorize access to this post/jobs between 1 a.m. and 7 a.m. Makes no sense, but hey, why not? Which then, with the defaults and overrides, lets us decide what it is that we really want to see happen down there, right? Probably the allow false, like not allow anything, and by default, is just a default up there, so not an override, so that now it can be overridden by HTTP routes down there for the application developer to say, okay, so how am I authorizing access to my thing? All right. The other one I wanted to focus on is rate limiting rate limit policy, which, as the name implies, lets you rate limit the traffic to your services. So that's a bit of an explanation of what happens on the right. Very fundamental. So it's a fixed window counter algorithm. I'm not sure if this matters quite a bit here. But the important part is the predicates and the qualified counters. When you look on the right-hand side, we have now the same predicate for the expensive operation that says when predicate writer in auth identity.group, which we saw from the previous slide. That being said, auth here is interesting. So unlike, for instance, the limit per IP that says, all right, we're going to do what we call variables for those counters, where every IP can only do 1,000 requests per minute in windows of 30 seconds. The predicate above there, like, reference this thing called auth that has nothing to do with like rate limiting per se, but it has to come from somewhere, right? Given what we saw before, you're probably already slowly seeing where I'm heading with that. So how do we make all that work? Stuff that we wanted to consider as we went through that is we want that stuff to be fast, right? That thing sits on the data plane. You don't want to be spending days resolving Fibonacci or whatever and having everybody wait forever. It needs to be relatively lightweight because it runs on the ingress or your gateway coming in. You don't want to run like a 20 gig memory payload down there. It needs to be relatively safe, both from us writing code and not bringing a gateway down is a very bad idea. Like, obviously, Kubernetes is going to restart it for you. Yeah, sure. And if you have two requests a day, it's probably good. But if your gateway is actually busy routing stuff all the time, you don't want to see random disconnects from your clients. Even if that's being taken care of, it's going to introduce latency. It's the give that keep. Nothing's free, right? We can only lie so much. So make sure that it runs relatively safe. The safe consideration, I'll get back to it later, because there's not only code that we write, the predicates that you saw are being authored by app developers, and we all know we cannot trust those. But yeah, make sure that those work. Another thing is don't reinvent the wheel, even though it sounds like fun. Yeah, it's round. So use existing standards. You saw some of them before. And please do not write yet another proxy. So this is why you didn't see you didn't see Quadrant in the list of implementers of Gateway API, because that's not what we do. What we're trying to do is work with what's out there. So the talks is Envoy, and which is true. The stack that I'll talk about in a sec only cares about Envoy, but the rest really cares about Kubernetes, the standards, and how can we make that work for the most. So the way that ideally we would go about this, sorry, that's a bit small. So left-hand side is the client that calls into Envoy, emits a request, get me something. When that request comes in, now what we want to do is pause, effectively in Envoy terms, that request, and first say, is it authorized, right? So for that, Envoy has what's called a check request. That's part of the external auth, not sure how to call it, like protocol, I guess, that Envoy supports. So that's a gRPC request that calls to Authorino and somehow identifies what effective auth policy that you saw down there, what is to be enforced. That sends it to Authorino. Authorino now has two options. Either you do not pass that check, in which case it's pretty easy. 4.3 to the client, you go get lost. In the other case, we're fine. So now we get some information back in the form of what's called an OK HTTP response. And that can contain data that now we may want to keep. This is why I put this yellow, like sort of, it's not that visible, I realize, but the stateful Envoy state here, right? So that can send data back to Envoy. Now, Envoy, next step, let's say we want to do the rate limiting, needs to call into limitador, passing in this auth.identity that we saw before, right? Like, otherwise, am I supposed to solve anything down there, right? Certainly, if I wanted, for instance, wanted to do like a counter per username, for instance, right? Like I would need to know what counter to look up on the other side. Limitador being that service that makes sure that implements all the rate limiting, distributed clusters and whatever. But again, we don't care about this right now. So same idea. Oh, look at that. Like you passed your threshold. Sorry, come back later, too many requests. Or we're fine, in which case finally your service sees the request. Whatever needs to happen happens, and we can return an OK. The same applies for what we're saying here, like get something. If we would want to let the service know who called us, right? Data that we got from Authorino that maybe itself got it from your OIDC provider of your company or whatever, you can control that data flows. All right, so in order to get that statefulness into Envoy, like how do we make that work? So you can write native filters. Anybody has written any code for Envoy at all here? Okay. So you can write native filters. And native filters, you write them in C++. So sure, why not? But you need to patch now Envoy. And so now I'm forcing somebody else to use my Envoy or my version of Envoy to be able to do those things. So that didn't sound too good as an option for us. There is dynamic modules. They're actually like DL open, like you load a shared object. You ask Envoy to load a shared object that it then will interact with. That sounds kind of cool. Obviously C++, but Rust as well. That's a little safer. But if we do anything wrong, well, we bring the entire thing down. So, and most importantly, back when we started this, that wasn't an option, so we didn't really consider it. But that's one that exists today, so you should know about it. So then Wasm extension, theirs sounds safer. We'll look in why in a bit. It was experimental, but hey, why not? And then there's external processing. So external processing was probably the most mature option, but sadly enough, it's you run another process that Envoy will call into using gRPC, but with pretty potentially large payloads. So effectively, you need, I don't know how much you know, like how like a proxy works, but long story short, you need to copy more data around that you wish for, right? And that all takes time. Back to the first point, we want to be fast. So that didn't sound awesome. So, all right. Let's try Wasm. So Proxy Wasm is a project that came out mostly of Envoy and Google. It defines an ABI so that you can write Wasm code that then, not sure how to put it, that then Envoy knows how to initiate a discussion with, and you can also talk with Envoy back, right? There are a few existing SDKs. So AssemblyScript, C++, Go, Rust are options. So they all leverage the same ABI. All you need to do is compile to Wasm and then run that module. There's a few forks of that SDK, and I'm going to be honest, including ours by now. I'll get back to that later. But one good news is that it's not Envoy specific. So Nginx, OpenResty, Apache Traffic Server are other proxies that actually support the quote-unquote standard, right? So that sounded good, back to what I was saying, right? Now all of a sudden, what we care about is Kubernetes. That's what we're talking about, right? So we could move that target different implementation of Gateway API. So what's Wasm? That's a bit of a pun slide. I expect everybody here knows what Wasm is. But so I took the 4 bullet points from their website. So it's efficient and fast. Yeah, check. That's what we wanted. It's safe. Check, that's what we wanted, because you run in a sandbox, right? There's nothing really that you can do unless the hosting Wasm runtime actually exposes that kind of options to you. They say it's open and debuggable. They're not wrong, but they're referring to the text representation of the opcodes. And it's true, if you like reading assembly code, yeah, you can figure things out. Debugging stuff in Envoy when, let's say, stuff hits the fan, well, that's a different story. And it's part of the open web platform, but we don't care about that. It's part of Envoy, so we can use it. That sounds great. And Envoy supports V8, what is it called again? WebAssembly micro runtime and Wasm time. So you get to choose how and what environment your thing is going to run. So cool, that sounds great. Like, I mean, checks all the boxes. So now we need to get some Wasm binary to Envoy to play with that. So how do you write Wasm code? So that's an old slide. If you're too young and you don't know, well, there you go. You're welcome. But I'm old, and I was writing actual Rust code back then already. So I thought it was just perfect. I kind of liked the aesthetic. So yeah, we chose Rust. So who here writes Rust or has written any kind of Rust? Okay. So this is a bit of a chaotic slide, but chaotic good. So the first part, as you see there, the lib crate type equals CDI lib, is actually what you need to put in your cargo.toml to write any kind of Wasm extension to Envoy. Then there is a bit of, like, literally, I even think the implement context for nothing is just to be very expressive of what I mean. I don't even think we need that, but that's a minimal set of Rust code that you would need to write in order to get your thing to be loadable by Envoy. And then you would just cargo build that project, targeting Wasm 32, because yeah, it is 32 bits, and WASI preview 1, because I think somebody knows if preview 2 is actually really out, or I wasn't sure. But anyways, the proxy goes with the integration all up, the proxy Wasm SDK goes with the integration up to that, because I don't think anybody has done the work to make it work with P2. Maybe it does work with P2, but hey, I guess if you try, you'll figure it out. Right, so that's the most simple that you can do. So this proxy Wasm main effectively does a little bit of magic that creates this thing. So the deleted argument there is a context ID. That's of some type, context ID, I think. But so effectively, that is your, and it does the magic to declare the entry points so that when your module gets loaded, Envoy can initiate the whole thing. So what is the whole thing, right? Because we only care about dealing with requests on the wire. So this root context that you just saw is actually tied to the VM plugins life cycle, is how I like to put it. I guess we'll get back to that a little later. And that's a thing that Envoy will use in order to create an HTTP context or a stream context, but I'm not going to go into that one. I'm only going to stick to HTTP for this thing. So what's an HTTP context? So it's actually a method that you need to implement yourself. So what you saw, those traits all have default implementations for many callback methods, I think I would call them, right? That will do stuff. By default, they don't do anything. So it's up for you to implement them. So we need to create a new HTTP context when our request comes in. So that's what our the code that we would need to write in our root context. And so what's an HTTP context? So it's that. As you can see, this is, okay, now let me go over it. So on HTTP request headers is when you pass the request header face. That means like the proxy saw all the headers, right? What you see at the end of stream could mean we're actually done. There's not going to be a body, and there's not going to be anything trailing afterwards either. But what I want you to take away is actually how this does very literally almost nothing, right? What we do is we invoke something inside your Wasm runtime on request HTTP headers, like passing it like one usize and one bool, right? That's pretty lightweight, right? I didn't push like all the headers into, like nothing happened. Lightweight. And so for all those phases, we can say what we want to happen. Either let the proxy continue serving the request as it sees fit, or pause. Is what I mentioned before, so that we can do our stuff. So how do we do our stuff? There is still on this ABI what's called host calls that we can invoke using the WASI. So think of WASI of a way of declaring like system calls, right? Your host like says, oh, I have all those things that you can call into me, I guess. So what I want to do is be able to read data, right? Learn stuff about the request being served. And as you saw, make, in our case, gRPC calls. You can also make HTTP calls. I don't want to speak more than that. I don't think you can open a plain TCP/IP connection when you probably makes sense. But what you can do is plainly hijack the request response thing, right? Like you could be very evil with that stuff. Like the service never sees what was asked. And as you saw in the flow that we had, like sometimes the service doesn't see anything and we decide what kind of response we send to the client. So this is a bit like how that stuff works. So that's the ABI. This is trying to get header map values. So the headers are considered a map from which you can retrieve values. As you can see, this is pretty lightweight because that lets us ask for a specific header. I don't need to copy all the headers again back into my runtime. I can just go to what I want. And that's the only data that's going to be copied around. Because just in case it wasn't clear, the way this works is that the proxy will try to not look at data as much as it can, but when you ask for data, then it's going to need to get that possibly in its heap itself, and then we need to do a memcopy from that heap to the whatever runs your Wasm, right, inside that heap. So that's the gRPC, doing a gRPC call. As you can see, it's a bit annoying, but the SDK comes with nicer APIs on top of it so that you don't need to do math like what is the size of this thing, where is it, and so forth. You just pass a slice of a string and you let it figure it out. Generally, again, everything is made so that you can see that even in Wasm, we can avoid unnecessary copies, right? All right. Yeah, so I put this slide up because additionally to all that we just discussed, there is a test framework that exists that lets you load your whatever module you wrote and assert about the interaction it has with the host. It is useful. It is arguably somewhat painful to use and to write, but I would strongly recommend if you're going down that route to do this, if only because once it's done, you can sort of automate that running. It's a bit slow as well, I'm not going to lie, right? You need to start up a runtime, like compile the Wasm to native and so forth. But who has written Rust targeting Wasm here in the past? Right. So you know that feeling when you import a library and you're like, yeah, it's so cool, that solves my problem, but then you can't target Wasm with it, right? So that's a nice way of making sure that all really works the way you want up until the end. So but given all the problem that we have, there's more considerations that we need to consider. What you saw before, like those predicates here, are actually common expression language predicates. So who knows about Cell? So that's a language that came out of Google, mostly targeting Kubernetes, which is one of the reasons that we actually chose it, because we want to be Kubernetes native, quote unquote. So you're avoiding forcing the users to learn yet another language. So it's fast. It is somewhat portable, i.e. there is a Golang implementation, there is a Rust implementation that we can use to compile into our Wasm engine. So that's pretty cool. But I'll get to more details on that later. It is extensible, so it comes with a set of features, and you can add more to it. More importantly, it's non-Turing complete, and it's immutable. So there's nothing you can mutate, and there is, technically, like, we should be sure that everything has a known cost model. Has a known cost according to the model, sorry. And it's safe. And it's really type safe. That's really great. So it leads to write a little bit of very crappy style, functional style code. I thought that was a good thing to share with you here. So if you want to play with that stuff, you can actually scan this QR code. That's going to open that code in a playground. Is it obvious to everyone what this code does? Okay, because I came up with it. I think it's very horrible, and I'm very sorry, but you can't even do bindings, right? So I need to pass this entire thing around and be able to check what I want to do. So what I want to do is effectively know in what plan some user sits according to some predicates, right? So I have this map, which is a set, right? So unsorted. So that's why I have the list at the beginning. I go, let's get to find which one are the predicates that all match based on the requests that come in. And then I take the thing out again and take the first result that's still left in that list. Sorry for this. I mean, I don't feel really good about it, but it works. So anyways, but it's extensible. So again, if you want to encode, let's say, domain-specific stuff in there, maybe you don't have to have your users. Oh, maybe they deserve the pain. I don't know. I don't know your users. What's really great about it is this, though. So what we can do is we can parse the entire expressions. We can check them for correctness, including depending on the context in which they will live. So instance, back again to my rate limiting that references auth. What if there was never an auth phase before that, right? It can get reasonably easily out of hand when you think about this DAG and this and that, and effective policies applies. It could be that a request can come in and you want to enforce a rate limit policy using auth, but no auth phase happened, right? Plus beyond that, all that can be changed at all times. So how can we make sure this works? And what is the cost of all? Again, as I said, there's a cost model associated with that, so we can know how much something costs, so we can push back on the user and say, well, maybe you should. Do you really want to do this? It's all that we can do on the control plane beforehand. And ideally, even though we're not there yet, that's why I said we can then share the EST across all the implementations. But the Rust implementation of the cell interpreter is not using the same ANTLER-based grammar, and things are a little bit out of whack. I'm currently in the process of trying to make that AST portable from the Go implementation to the Rust. But yeah, let's say Rust C is not entirely happy quite yet. Well, I'm not done with that, effectively. Which can get us the validation that I just mentioned, right? Make sure that on the control plane, everything's fine. And on the data plane, what really matters is you must not fail, right? Because at runtime, that's not when you want to tell users, oh yeah, well that doesn't work because when request foobar comes in, there is no auth. We want to catch this very early and let the user know. So we start building more and more tools around this entire ecosystem. So one of which is what we call the Policy Machinery project. It actually computes a DAG of all those Gateway API network objects, the policies attached to them, and that then in return lets you, according to the merge strategies and so forth, let you calculate your effective policies, and including the request that should come in and that now the proxy needs to know about in order to do that. You'll get more hands-on in a bit. So this is sadly now where conference-driven development not always works. So I was hoping that would be done with all of the work that I'm going to show you now. Well, me and my team, because it's not only me. Actually, the reason we're late is my team. Oh, that's not recorded, right? No. The reason we're late is me. And yeah, but that's what we're trying to build here. Provide the proper abstraction so that people don't need to suffer from all those low-level details that I just explained to you. There is no possible presentation without a Dijkstra quote, so we're done with that. So effectively, what we're trying to build is a custom controller pattern like that's a little bit smarter. And what do we call smarter? So if you've never seen that kind of code in your life, I'm sorry. Plus, it's Go code, so double sorry. But effectively, that's something that tries to reconcile like the desired state towards the actual state, right? In this case, this is actually stolen literally from the example from the Kubernetes website. There's only a few changes here. And that's the important part. What we're trying to do here is instead of setting a random, I think, world into the hello label on the gateway, what we're doing is actually using the policy that we're currently resolving for in order to find the gateway that it maps to, finds its name, the name of that gateway, and tag our policy, our policy with that, right? So that's what we're trying to do. The key part is the self thing. And I'll get back to it. As you can see, that's a set expression. It will go a little bit all over the network, but we'll make sure it works. So let's say we want to build like some redirect to newest host name policy. So remember the graph that we had at the beginning. You can have multiple gateways. You can have multiple host names. You can have multiple listeners that themselves have multiple host names. So we want to always redirect to whatever is the latest host name that got wired into this mess. That seems easy enough. So as soon as something comes in, right? So find all the HTTP routes that are affected directly or indirectly, find the newest gateway that's attached to them, find the listener in there, take the host name, and if the request comes in and it's not using that one, we just redirect it to the new one, right? It's like, I mean, how hard can that be? So again, find the newest, redirect. So this is pseudocode that, let's say, would do that. So policy, find gateways, reverse, because the eldest one is the first one. So we reverse the thing, we find the youngest one or the most recent one, get the first listener out, get the host name, and do the redirect, right? That seems about what somebody would want to write. The problem is that that line is not a data plane thing. That's all the stuff that happens on the control plane when you wire your entire world up. So it's a bit of a twist on the previous slide that you saw before, where that here is what we saw with getting the name of the gateway, right? Here, because that got caught by our SDK. By the way, all that works, so it's not public, but all of that, well, it's open source, so yes, it's out there, but it's not released. All of that works. So what we do now is you can write your reconciler for that redirect to newest hostname policy thing that you introduced. And the last parameter that I see there, true, says I care about knowing whenever that changes. So to you, the fact that your policy changed or something that affects your policy has changed, it all looks the same to you. It's just a good old reconcile loop, and you do whatever you have to do. What you have to do down there is inject the hostname inside the Wasm shim config. What is that? So the Wasm shim is this Wasm code that we run inside Envoy. It gets a thing that I didn't mention, like the root context also gets told as a callback that's called onConfigure. That's going to inject the configuration that you decided to pass to it, right? So you have absolute control over that. So this is the way that we do this today. Now you should more or less be able to reason this out. So the route rule conditions that you see there are derived as cell predicates, I should say, from the DAG itself, automatically for you. You don't need to know. Here, what I'm implying, there are two gateways, or at least two listeners, one with toystore.com, the other one with example.com, right? And what we only wired that to an HTTP route that only honors get. So we have a predicate that says if method is get, then that's what we care about. That part of the logic is the mapping to the DAG. The effective policy is what is underneath, the actions to be taken. It's plural because there could be multiple steps, right? So the predicate that you saw is the one that we wrote that we looked up the hostname for, so that's now hard-coded, right? This says that we first had the toystore.com, but then we bought example.com. So if the predicate, if the hostname, the requested hostname is not example.com, we just trigger that thing. So what we need to do is write this redirect service. And we would be done. Well, do we really though? I don't think we do, because if you squint really, that's the part that's we're currently implementing. When you squint like really hard, actually all we do is always the same. It is, you get a request in, possibly you pause, that's the logic with the route rules predicate. Then possibly we call to a service, we get a response back, and then based on that response, we do something with it, right? So either we allow that thing to continue down the action chain, or we hijack the response, right? Well, we could express all of that in those config bits, and you would not need to do anything like that. That sounds maybe a little bit crazy, but there's a few things that I need to mention here. One, Cell has support for protobuf messages. And gRPC has support for introspection. So I don't need all the details, right? And then there is data. That's the fun part. That's the data dependency in your chain. Where does something come in so that it can be evaluated and make sure that it works? That one's a little bit hairy. We're on it. So that's what we're trying to build effectively, is I would say, framework that enables domain experts to write what we call meta policies. Effectively, a thing that sits very close, easy to understand for the person that's going to be writing, let's say, the OpenID Connect policy. They would only see wording from the OIDC domain. They don't care about Wasm and all that, right? So that's what we're trying to achieve. Now, is running Wasm the best thing? Well, observability, metrics are so fine. There are callbacks that you can use so that your envoy can send metrics. Logging, get all intertwined with the logs from the envoy, but that's not really surprising, and you can do stuff about it. Tracing has been more interesting. We hit a few. If you need to have the trace ID coming from envoy, like they seem to be a little bit of a lossy situation in certain versions. Envoy itself has been somewhat surprising, but I said at the beginning, right? Support is experimental. Certain versions, I'm pretty sure that's now fixed, but if your code would panic, your Rust code would panic, like Envoy would get in a really weird state. It wouldn't crash, but you would lose a worker. Well, that's a problem. And talking about panics, the SDK itself panics, which is the reason we forked it. We believe it should never panic. More work going on is obviously with AI. No talk would be complete with Dijkstra or AI nowadays, apparently. So because there is a Gateway API inference extension coming, we're looking at what this would mean for us and how we can use this again as a domain for others to use. But my question is to you, what do you think your situation could make use of either of all the stack that we went through here? And I think it's interesting to think how you can abuse the infrastructure that's given to us. Like, it's forced upon us. We have all those tools. Let's go wild, let's use them, think out of the box, and maybe it's gonna be a bad idea, you'll figure it out. But that is it, it's from me.
Thank you, Alex.
Thank you.
There is a question from? Yeah, I have a question.
Yeah, you mentioned that like debugging was painful, and that I was just wondering if you could expand a little bit more about that and like what's available to help you.
Yeah,
debug
well,
things.
okay, maybe the gray in my beard gives it somewhat away, I've been doing this for a while, so my solution is println, which is a lie because I'm actually logging, because I cannot println because println wouldn't mean a thing in an environment like that. So I don't know of any solution to be able to attach a debugger really neatly into that, right? What is it really that I'm getting from, you saw like some of the signatures, right? What is it that I'm really getting? There's one that I didn't go into. You can read certain, cell is itself used in Envoy, by the way. So you can resolve like request.method, for instance, in a given way. But one thing that hit me is request.timestamp. And the doc says this is represented as a gRPC timestamp thing, which is, if I remember right, 12 bytes? So 8 for whatever to what precision, and then another 4 for the remaining precision, right? I'm like, oh, it must be that. And I read those 12 bytes. Well, it turns out it wasn't that. It's 8 bytes, right? But then how do you debug that, right? So we wrote, for instance, an entire thing that for every environment in which we can run, we can, for any request, have the description, like the layout of the data that we get back from the host given to us, right? That's the kind of thing, I don't know, but like that you would use LLDB or, like I don't expect to have to do those things like that. So the answer is println debugging. Am I proud about it? I don't know.
There's another question. Okay, so there is.
Well,
thank you again.
yeah, that's it. Thank you guys for attending.